In this example, we want to find dy dx using implicit differentiation. To do that, we take the derivative with respect to x of the left and right sides. Again, dy dx of left and right sides. Next, we can separate the left side, taking the derivative with respect to x of x cubed and the derivative with respect to x of y cubed. Now we go through and actually take the derivative. So the first term is written in terms of x, so that's just the typical rules. Derivative of x cubed is 3x squared. The next term is written in terms of y, so we're going to have to use the chain rule here. The derivative of y cubed is 3y squared, but we need to multiply by dy dx using the chain rule since that term is written in terms of y. And on the right side, notice we have the product rule. We have 6x times y. So product rule. First, 6x times the derivative of y. The derivative of y is 1, but we multiply by dy dx because it's written in terms of y. Plus the second times derivative of the first. Derivative of 6x is 6. Now we can simplify and group terms that have dy dx to one side and terms that do not contain dy dx on the other side. So I'm going to group all the terms that contain dy dx on the left. That means I need to subtract 6x dy dx. And terms that do not contain dy dx, I'll move to the right side. So 6y is good on the right, and we need to subtract 3x squared over. From here, keep in mind our ultimate goal is to isolate dy dx. So let's factor out dy dx on the left, leaving us with 3y squared minus 6x, and copy the right side. Finally, we divide, and dy dx is 6y minus 3x squared over 3y squared minus 6x. Notice in this case, the two terms in the numerator and the two terms in the denominator contain a 3. So we can reduce this. 2y minus x squared over y squared minus 2x. And we now have dy dx.